2.4, solving multi-step equations. So we're going to solve these using addition and division, and there's really only, there's a better way to do this. And so if you look at this first one where it says solve each equation and then check your solution, it says 7m minus 17 equals 60. Let's look at the wrong way of doing this first. Well, somebody maybe would be like, well, there's a number in front of the variable. I want to get rid of that. So they divide, and maybe they divide here and there. But that's wrong, and here's why that's incorrect. Let's agree with a couple different things. Well, 7 plus 14 does equal 21. So first of all, if the person did that and they only divided the number on the left and the number on the right side of the equation, this would become 1. That wouldn't change. That would still be 14, and this would be 3. And 15 does not equal 3. So I'm demonstrating how that would be incorrect. Well, if somebody wanted to, they could divide every term, and as long as they did that, it would be accurate. But often, that's an unhelpful way of doing this, because it's a little bit more complicated of work. And what I mean by that is, well, 7 over 7 simplifies nicely. So that wouldn't be a problem here. But 17 over 7 is ugly because we're dealing with a fraction or a decimal, and the same comment here. So it's best to get rid of what is being added first by adding 17 to both sides. Which means on the left side, these two values canceled each other out, and we have 7m still remaining on the left, but we have 60 plus 17 becoming 77. And before you move on, I want you to get your eraser out if you feel like you can't draw an almost perfectly vertical line between your equal signs. The work that you do on the left side of the equation is balancing different parts. The work you do on the right side is balancing different parts. So this has to be completely in balance. And to make that the most clear, you really need to write your equal signs below each other and keep all your writing consistent. If you have 17 written below here, that's inappropriate because 17 was written to cancel out the negative 17. So keep your work organized as best you can. Here we have 7m, and now we're left with a one-step equation, dividing both sides by 7, giving you m equals 11. We always have to check these. And now it's more clear why we do a check. It's because it's more steps involved. 7 times 11 minus 17 equals 60. Well, we figured out that 11 was m and substituted that value back in here, and we're checking to make sure that once we do that, the left side is equal to the right side. 7 times 11 becomes 77 minus 17, because I'm just rewriting minus 17, equals 60. Look at where I put that equal sign. It's exactly below. In the left side of the equation, 77 minus 17 becomes 60, which is equal to 60, and I'll put a check mark there. The left side is where we designate our algebra. The right side is our check, and over off to the furthest area, if we needed to do any scratch paper type work, we would use that area on our spirals. These problems get more and more straightforward as you practice them. 2x minus 6. It's usually most common to take that minus 6 and avoid having it, so let's add 6 to both sides. I'm writing that where the numbers are below each other, and I'm not writing it below the variable because the 6 is detached from 2x. On the left side, the only thing that remains is 2x. On the right side, 4 plus 6 becomes 10. Then I see a 2 and x, and I know that that's multiplication. And the opposite of multiplication is division, so I'm going to undo x. I'm going to undo what it has there. And I guess a little friendly reminder here, is this completely solved? Well, it is completely solved because x is by itself. If I had negative x, that would not be completely solved. If I had 4x, that would also not be completely solved. So for this to be solved, you have to have only x on one side and just a number on the other. Plugging 5 back into the original equation gives me 2 times 5 minus 6 equals 4. I simplify the left side. I rewrite the right side. 4 equals 4. Check it. Before I say that this problem is an OYO problem, which it will be, remember that it doesn't really matter that this is written over here. It's just going to change where you have to deal with the variable. So before you make this OYO, if that's going to bother you, rewrite the equation with 3y plus 7 on the left and 8 on the right, because you can change that order, and if it helps you to see it, go ahead. If not, just do it the way it's presented. But again, this is an OYO problem. In 5 seconds, I'm going to put the results up for the work. I've paused at this step before evaluating the fraction part just to talk about that. 1/3 can't be simplified anymore, so that's fine there. Let's check it though, since it involves a fraction. 8 equals, well, 3 over 3 becomes 1, and the only other thing that's in my numerator is that 1. So I'm going to write 8 equals 1 plus 7, and 8 is 8. So even though that had a fraction, that did check out. Now these say using addition and division, but of course you might have to use subtraction and multiplication. So we'll do problem 4 together. T divided by 8 plus 21 equals 14. First, let's deal with either the 8 or the 21, but the 21 is the better decision. To get rid of the 21, I'm going to subtract 21 below the numbers, doing the same thing to the left as I will the right side of the equation. And when I do that, the 21 goes away on the left, and I have t over 8 equals negative 7. The opposite of division is multiplication, and we've done these as one-step problems. So I'll show multiplication on both sides. I chose that because 8 over 8 simplifies, leaving me with just t. And 7 times 8 is 56, and I'll sneak that minus sign out front. Plugging it back in, I see negative 56 over 8, and I do try to like to use one line of math paper if I can write it small and neatly. Well, 56 over 8 simplifies, and the negative stays there. And negative 7 plus 21 equals 14, and 14 does equal 14. Now when you're dealing with fractions as well as negatives, there's definitely some uncertainty. So plugging this into the calculator is a good decision. Plugging this into the calculator is a good decision if you are uncertain. It's good to avoid crazy amounts of work for every problem, but you might not want to cut a corner if you think that a part is challenging enough to where you might make a mistake. Before we continue other types of problems, we'll stop this video here, and this is the first video for solving multi-step equations.